same job that division does. So it's synthetic division. Yeah. We did some of the
Yeah, that's what I'm reading.
we didn't do the practice problems, right? Alright, so let's see, let's remember from Friday. We had the 19th. Today's the blue shot day. Technically, right. I want to write that and that front. And then that. Okay. Yeah. Okay. So if I need to rewrite this for synthetic division, okay, synthetic division. Positive 2 goes in that little L thing, okay? Okay, and then what do we do?
From the one down,
Okay.
we multiply 2 times 11.
No, you don't subtract. You add. 2 times 4. You add these. No, you don't subtract.
I mean multiply.
Yes.
You said subtract.
You multiply 2 times 1 over 2. Add. Then you multiply these 2. Write the answer here. And add. And you multiply these 2. And add.
Okay, so you multiply by that too.
Yes. You always multiply.
There's no remainder.
There's no remainder. Right. Okay, so what's this called? Do you remember the rest polynomial? The answer is x squared plus 4x plus 3. Now, because there's no remainder,
What?
see the remainder is 0.
I'm an idiot. 2 times 3 is definitely 0.
Because there's no remainder, x minus 2 goes into x squared plus, or x cubed plus 2x squared minus 5x minus 6 evenly. So that means x minus 2 is a factor of this polynomial. Like 4 plus the 32 evenly. 4 is a factor of 32 because this goes into this with no remainder. It's a factor. Okay? That actually has a name. It's called the factor theorem.
Let me guess, the guy who created this name is factor.
No. It's because if you divide and the remainder is 0, then what you just divided by is a factor.
You're close, Jeremy. You're close.
Yeah.
You're pretty close.
Right there.
Got a crush on creativity.
Yes, I did. What I do? I'm measuring pressure.
No, she should have a dream catcher, break it, and hang it up, says it's a dream crusher.
Alright, so here's one for you. Is x plus 3 a factor of x to the 4th minus 25x squared plus 144? Alright, to find out if it's a factor, You're going to use synthetic division. What do you notice about this problem, though?
There's no x to the third or x.
Right, there's no x to the third and there's no x. You got to fill those spots in with zeros. So you're going to use synthetic division. If it's a factor, what's your remainder going to be?
0.
0. And if it's not a factor, then it's anything but 0. Okay? Alright, so try that one. Alright, what's going to go here? -3. And then I'm going to put a 1. Alright, a 1 and then a 0. -25. Another 0. And then 144. Why do I have those zeros there? Exactly. There's no x to the third and there's no x. Okay, so 1 comes straight down. Boom. -3 times 1. Yes. 0 plus -3. Yes, it is. Awesome. Okay. -3 times -3. 9. Okay. -25 plus 9. -16. And then when I multiply those two, I get, I sure do, 48 plus 0, 48. 48 times -3, -144, the remainder is, so is x plus 3 a factor? Yes, it is. Why, yes. Yes, it is. Awesome. Okay. Some people are still writing this down, so I'm going to give you a second, because I'm going to talk really mathy to you for a minute. Like some real serious math stuff. Alright, you got it? Okay, so this problem was x plus, or x to the fourth minus 25x squared plus 144. When I graph it, it looks something like this. That's what it looks like. And x plus 3 is one of its factors, which means at -3, it hits 0. Okay? A factor is a solution, is a 0, is an x-intercept. They're like all the name for one particular thing. So on this problem, if you were to put -3 into this problem, your answer would be 0, because x plus 3 is a factor. Okay? That means it crosses right there. There are 3 other zeros that we're not going to worry about right now. We just want to look at this one. Okay? But because when I put in -3, I get 0. Over here, when I put in -3, I get 0. Here's what's great about this. Because this works, if I need to find out the value of any number at all in this particular function, I can use this synthetic division to find out the value of anything. Okay, it's called the remainder theorem. And if you pick a number, you want to know, well, what's the value of that function at 20? You can put 20 in, and whatever the remainder is, that's the same thing as if you were to put 20 in for x and take 20 to the 4th power minus 25 times 20 squared plus 144. Because the remainder tells you what the y value is on this function. That's what it does. That's how we know that when the remainder is 0, we've crossed the x-axis. We've reached a factor. We've hit something. Okay? So let me show you what I mean. Alright, x to the 4th minus 3/5 x squared plus 144. I'm going to forget that. X to the 4th minus 25x squared plus 144. Okay. So let's say I want to know what happens when you put, let's not be 20, because I just said that one. Give me another number. 35. Okay, 135. Alright, so I want to know what happens at 35. Okay, so at 35, I could do this two ways. I could either put 35 to the fourth power minus 25 times 35 squared plus 144. I can do it like that, or I can do it like this. So that's 1, that's 35, 35. I put 35 times 35 there, 16. Alright, 1, 2, 2, 5. So that's 1200. And I'm up by that times 35. Yeah. And then 35 times over 2,000. 1,470,000. Alright, so I'm going to say that's what happens when I put 35 into that problem. Yep, that's what I got. Okay, so you're like, well, that's just as fast to put into your calculator, so I can just put it into your calculator. So sometimes it's not as fast. You have x to the fifth. And you want to know at you want to know what happens at f2. Okay, it's going to take you longer to get this in your calculator the right way than it is to just put 2 in and work it out. Okay, so you can put 2 in, or you can just bring that down. It's 2, that's negative 2, that's negative 4. That's going to be a negative 8, a negative 6, a negative 12, a negative 17, a negative 34, or negative 28. So if I were to put 2 into that problem, I would get negative 28 for my answer. That's just a shorter way. It's called the remainder theorem. And it just says that when you put this number in, you run it through synthetic division, the remainder is the value of the function at that particular number. The remainder theorem. Okay? I'm going to give you one to try. It's just synthetic division. The difference between this and synthetic division, though, is that you don't have to change the sign. And the reason you don't have to change the sign, with synthetic division, they're giving you the factor. With remainder theorem, they're giving you the actual value. Okay? So, I don't remember these. As soon as I turn away, it's out of my head. There you go. I need a 10 here, a negative 2, 3, 2, 1. Okay, so I'm good on that. Another negative 2, a negative 1, and a negative 20. It's going to be negative 2, negative 20, negative 22, 220, negative 221. Oh, let me just keep writing 2s. Negative. Exactly. Don't change the, if it tells you exactly what to put in, don't change it. Yeah. Alright. Remember when, like, think way, 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 way back when you were factoring quadratics a couple of weeks ago, and you ended up with, like, x plus 2 times x plus 3. And those are the factors. If those are the factors, then the actual zeros are x equals negative 2 and x equals negative 3, right? Because you do x plus 2 equals 0, so x equals negative 2, and x plus 3 equals 0, so x equals negative 3. So, see the difference between a factor and what x actually equals? This is why you change the sign when it's just synthetic division. When it's like, divide this by x plus 2. Okay, well I actually have to put in negative 2. Because this is the factor, but this is the number that I'm actually working with. You see the difference between those? So if it gives it to you in like x plus 2, x plus 3, x minus 7, whatever, you have to change the sign. Because that's the factor, but the number you're working with is always the opposite sign. But here, see the difference here? They gave you the number. There's no factor. There's no x minus 10 or x plus 10 or x. There's no x. It just says, find out what happens when you put 10 into this. Okay, so just put 10 in. Okay? If it says p of x is this, divide by x minus 10, well then you have to change the sign. But as it is, you just leave it just like that. Okay, so you see the difference now, why one sign gets changed and one sign doesn't. Okay. Alright, so let's try one more. And then I'm going to let you do some work. Because I know how much you love work. Right? No?
I'm ecstatic over how much work you're doing.
I know, right? Do you dream about it?
Yes, I dream about it in my nightmares.
When I was in college taking calculus, I would like dream answers and wake up and like hurry up and work it out because I was so consumed with that class that I would dream about doing the math. It was crazy. Alright.
Only math-related dream I had was, like, I think it was right after I watched Die Hard 2. So when they get that little bomb, they have to put a certain amount of weight on it.
Yeah.
You have to do that math. Yeah, it's pretty much exactly like that. Instead of Bruce Willis as me, and instead of the other guy was Juan.
Really? Alright, I'm going to put 1/2 here. 2, 3, 2, negative 2. 2 comes straight down with half of 2. So 3 plus 1 is 4. Oh, look at that. So that means, okay, so if 1/2 gave me a remainder of 0, then what's one of the, this is a 0, what's the factor? Right, x minus 1/2 is a factor. So the 0 and the factor always have to change signs. Okay? No, you were just looking for the remainder. This happened to be a factor. Yeah. Alright, get that page out, 3.1 from last week.